starting with the wine of the day, we have El Esteco, and this is from Argentina, so it's the Torrantes, which has a totally unique aftertaste that you're going to taste this once and you're not going to forget. I mean, you know it's coming. I mean, you smell it. It's not the smell. It just hits the same every time. It just comes on like wine and ends like what just happened in my mouth. So, hello everybody and welcome to episode 73 of Community Service Hour, broadcasting now live from Discord and Twitch, because Twitter sucks right now. This is a throwback article. Somebody was bringing up token curated registries. I heard about this. This is like really a word from the past that is very relevant today. You're listening?
Yeah, let's get into the blog post.
So here's the article. This is something called token curated registries. Let me give you the seminal paper on this. Token curated registries. This is the precursor to DAOs. This is the paper. This is the paper from 2017. You definitely want to read this. This is creating communities that are based on voting. Now, there's one major use case that's kind of behind this, motivating all this, and it's Augur. What is Augur? Basically, the way this works is you are betting on things. You're predicting whether something's going to happen. This could be predicting the outcome of a sports event, predicting the outcome of an election, predicting the price of a stock, which very much can turn into getting exposure to the price of a stock. You need to have a way that the blockchain, or this is a decentralized system, that this system can know the correct outcome. And that's a very important thing. We have oracles, which are trusted. The oracles can just set the price. This is a major problem of Compound back in the day. Augur, the way this is managed is through a system called reputation. If you have the reputation, then you can vote, you can stake, you can vote, and then it becomes, really in game theory, this is a popularity contest on what is the correct answer to who won the sports game last night. With the idea that people are always going to vote, the majority will always vote for the correct answer because they have more to lose in the value of the reputation tokens than they do to winning any one bet. So, well-known threat model. This is the major application. This is the one of the day from back then. Augur had a major impact on Ethereum, working very hard, testing the limits of what's possible and how much stuff you can run through the network. Augur's been a really big contributor and tester of these limits. Basically, it's a token curated registry. It is a list of things that happened or didn't happen. It's a predicate. And so this paper came out expanding the concept called Token Curated Registries 1.0. And it described what is the utility of these registries. And it looked at these types of lists, and it looked at how you can motivate the maintenance of this list on-chain by people with stake in the game. Specifically, having some type of a reputation token that will have some type of a value, whether the value is money or connected to some real-world reputation. It goes into there, and basically the concept of this paper is that these lists, there is a system, decentralized, trust in the rules, not trust in the administrator, that with a token can produce lists. And we can trust those lists if we trust the system, not the administrator. In other words, decentralized. This is the seminal paper. I have the second paper on this topic. This is several months later, almost a year later, from 2018, and focusing on the uses and exploits of token curated registries. Again, token curated registries, we're just talking about putting things on the list, but this is exactly the same content as a DAO. When we're talking about DAOs, we're talking about authorized decisions. They're the same thing. I really want to expand to real life, things that existed before blockchain, that will exist after blockchain. Did I just say that? Things that are real life scenarios. Governments, this includes organizations, real life things. And so my definition is players can vote, players can commit money. So money is more specific because in his paper, in Mike's paper, he was only talking about tokens, which may or may not be money, but I'm saying money. The result is calculated based only on the votes and the money. This is a broader definition because it's not a percentage of votes. because I'm also including things like quadratic voting, which is not always quadratic. I'm scare quoting that. And then 4, people agree to support the outcome of the vote. In other words, there is not a backdoor. There's not an administrator here. So one more time, players can vote, players can commit money. The result is calculated based on the votes and the money only. Everybody agrees to support the outcome. This is also related to the Continental Congress. In the United States, we have the Continental Congress voting on what should be the Constitution of the new United States. This is before the Constitution was finalized. They were talking about what are the rules that they want to support. England is hot on the tail, right? And so the way that they agreed to this, they did it in secret, and they had secret commit reveal voting. And the commit reveal, the way they did it was the commits were in the room and the reveal was public, and they had unanimous consent. So I don't think anybody was shot or left the room in a body bag, but the rule was you come into this room, you do things, and when we leave, everybody agrees based only on the votes that were done in the room. And we're not going to hurt each other's reputation by leaking different votes. We are all going to come out united. That was the agreement. And obviously this will never happen again because politics. But at that time, with life or death and Britain on the line, that was something that was able to achieve consensus. But the big thing that comes out of this paper is that in order to set up the voting, in order to securely set up the voting so that the votes represent the correct outcome and that the outcome is guaranteed, scare quoting, nothing's guaranteed, but reasonably supported by the parameters, you need to set parameters. Is the voting going to be 51%? Is the voting going to be done in a day, a week, a month? These are the things, these are the parameters for the voting. And if the parameters are set incorrectly, the voting doesn't work. I give a very specific example. One of them is for sports betting. If you've got a sports bet and you are dependent on 51% of the people potentially verifying the outcome of the sports bet, well, what if the sports bet is a local basketball game for a high school? Did you go to this game? What if it's not televised? What if you have to physically go there? Is it possible that 51% of the owners of Rep Token will go to a local game in Abington, Pennsylvania to watch the high school sports, which is not televised? Or are they going to just look at the outcome that the first newspaper publishes? Or what if the newspaper publishes the outcome, but then the outcome is revised because it was wrong? When you're making these systems, there is an assumption that all the outcomes will be knowable to everybody within a certain amount of time. That is an assumption that you cannot know at the time you're designing the system. Therefore, there's a serious problem, and these systems can never really be decentralized because the rules are the problem. The rules are cast in stone in these systems. That is the problem. Now, one of the weaknesses in my paper, in retrospect, 5 years later, is that this paper does not consider systems where the rules can change based on the votes of the system. Practically, it might make sense, but as a formalism, I don't think you can make a complete formalism around that. So this paper was really the biggest contest against token curative registries and therefore against DAOs. This is one of the arguments that I make where I say DAOs are never really decentralized. And in other words, nothing on Earth can be decentralized except for math. And we're not even talking about set theory axioms because those are centralized too. You have to pick the axioms. Even the axiom of choice, which everyone thinks makes a lot of sense. In set theory, you have to either work with it or not, and you cannot prove it in the system. I have a second paper here, also introducing, and this is the blog post in the Moondust series. Blockchain people have been to the moon and back down to Earth. We brought back Moondust. Moondust is the stuff we've experienced on the moon, through this blockchain, all these magical things in this blockchain world, which honestly, when we talk about blockchain for the masses, that's not going to happen. But what you can have are these concepts. The concepts that we saw on the moon, like payments that can't be reversed, mostly. Things that are based on digital signatures, cryptography, Merkle trees, signatures, digital proofs, Shamir's secret sharing. These are things that we can do in the real world. We can use different words, we can build them into our products, This paper is the first in a series that documents one of these things: auditable, versioned databases. Goes into what is a database, what is auditable data. The way I define it is something that is authorized by a specific person, whether that's a digital key or an attestation or whatever. I go into these things broadly. It's canonical. Canonical means that if you submit your taxes, if you have 5 versions of your taxes and you only submit one of them to the government, that's the canonical one. And the other ones don't count. And when you get audited, that same one that you are reporting on needs to be available. And then the last thing is you need to have some type of evidence. So when I use the word auditable data, I'm referring to something that is authorized, that can be traced back to a person, canonical, that is exclusive, and with evidence. And I get into what is the evidence, what is the evidence we rely on in the real world? Pretty flimsy. It's based on threat of lawsuit. Maybe you're standing on shaky ground in terms of the things that you're depending on. Nevertheless, we look at that, and then we also compare to blockchain, where they're based on signatures, irrefutable evidence. So this paper looks at evidence beyond a reasonable doubt, irrefutable evidence, and then goes into how we can apply this to business data, simple things you can do on your own computer with the existing software you have to try hashing files, creating a database. It's got SQL code. It's got code that we looked at last week, cleaned up a little bit. I went through it again and cleaned it up. The incremental business, the incremental money that you can get by adopting these things. We're not trying to reduce costs. We're trying to do better business, things that move the needle. And that's possible. If you get audited, they're like, give me all your data. That sucks. Instead, if you use commit reveal, something we learned on the blockchain, something we learned on the moon, right? If we're like, here's all our data, we've committed to it. Tell me which ones you want, and I'll prove I'm not going to bamboozle you. I've got 1,000 here. How many do you really need to audit? Pick 20. Here's 20. Oh, you want 20 more? Here's 20 more. You've revealed 40. It's not necessary to reveal 1,000. And the way you get there is little moon dust. These approaches work. They're there. We can use them.
Doesn't that require a lot of buy-in from the auditing body? Otherwise, if they don't have any concept of Merkle trees, then it's not going to be convincing to them.
I've spoken with regulators. I've been on the phone with these types of people, and they're never prescribing the practice. I had a lot of phone calls with the Food and Drug Administration, the U.S. Food and Drug Administration, and they're not going to say, we endorse blockchain. But they will say is, we love the ability to audit something and tie back to something that you committed to 3 years ago, as opposed to whatever records we found when we showed up today. And you show up at Enron and they're like, well, we've got a bunch of confetti. Would you like that? And they're like, you suckers! Like, that's what you're working with as an auditor, right? So anything better than that is a win. Now, the auditors will never, and when I'm saying auditor, I mean regulators, not industry like AICPA. AICPA can make rules, but looking at SEC and auditors in this direction, and Sarbanes-Oxley, they're never going to give you methods. They're going to say what they want, and they're going to look for industry best practice. If you can demonstrate that commit reveal is industry best practice, if you're a big company, there's a difference between revealing all of your business records and just the ones they want. It might be worth it to put somebody on retainer for a few hours to explain why this is best practice. It might make sense to go to your industry trade group and sponsor an article on this topic. It's a smart move.
Right.
That's another thing. On the other side, they don't want this. Guess what happens when you send an auditor 1,000 things and they only look at 20 of them? Well, the other one down in the bottom of the list that you didn't look at had a problem. And then you have another thing like, what's his
Arthur Anderson.
Arthur Anderson, right. Arthur Anderson would love to say, we only saw 20 records and all 20 of them were good and we picked them randomly using the S&P 500 closing price. Big random numbers that you can verify. We only saw 20. Here's all the data that came in. We have all the emails. Audit the auditor. They would love that. As an auditor, that's a liability too, because you're signing these papers, right?
One specific example that comes to mind is all those emails of tech CEOs that are out in the open. Apple probably didn't want to release all of that. If the regulators were bought into a system like this, then that would be a way to release only the emails related to what they needed to release.
Here's a 1-minute approach. Have a version database for your emails built into Outlook somehow or whatever. Get audited. Take every one of your emails and hash them. Take every word in every one of your emails and hash them in separate databases for each word. Present your hashes. And we invite you to pick 10, 20, 1,000, a million of those emails just to validate what we told you is true. So the step 1 is go pick 50 random words, verify those words, go into the emails database, and then see, was that every email that was selected contained that word? Number 2, pick 10, 5, 1,000, a million emails from our emails database. Take every one of those out. Find that word. Then let me prove to you that that same word is in the index database. And this can also be done with zero knowledge proofs, but we're ignoring that. With enough rounds, I can convince you that the data is complete. It ties back to my Outlook database version on that day. It ties back to every email in the database, ties back to every keyword. Stage 2, tell me all of the words you want to do a search for. You give those words to me. I look them up. I provide them to you using the same process. And so you can be confident that I'm not hiding any words like Hillary Clinton. They're like, Hillary Clinton, can you tell me all the instances of classified data you had in your emails? And she's like, oh yeah, no problem, bro. Let me just go through my emails and return them to you. Oh, didn't find any. Oh, okay, thanks. That's how that worked. Now imagine that same process with the Will Entriken version database here, right? You had to commit and reveal ahead of time. You've proved the authenticity. We could use zero knowledge proofs. And then all this data comes through and then there's nowhere to hide. The only thing you can do is say, oh, email 75581. Yeah, I know I told you I had that database. I know it's in the indexes over here, but I accidentally lost that email. Sorry, I can't give it to you.
Yeah, I think the worry for companies would be they want plausible deniability.
That when they delete the records?
Yeah.
So yeah, they could have deleted those records. Maybe, now it's a conspiracy and you're, if somebody leaks, if somebody says, oh, well, the CEO told me to delete the email before the FBI investigation and I kept a copy of it. I mean, that's immediate jail time. Like that goes from oh, I donated to people, so I'm not going to get in trouble with regulators to I'm definitely going to jail because I'm impeding an FBI investigation. Like there are different levels of.
Right. Yeah, it seems like a no-brainer. But anyway, I feel like this moon dust idea has legs. I think that's the right way to think about it. And I haven't heard anyone articulate that before. It's either to the moon or the moon never existed, so shut up about it. And you're proposing this third and actually quite reasonable way, which is, hey, there was a lot of experimentation with interesting technologies over the past couple of years. Instead of saying we're going whole hog into a brave new world blockchain future, what are the things, what are the pieces we can learn from this that can just be applied incrementally to existing systems and make those systems better? And it also doesn't preclude the idea that, there's some beautiful mainstream blockchain future in the future through just building up this stuff over time. But it's not one or the other. In fact, it probably never was, right? It was, and I think this is a smart way to approach how to use pieces of this tech in the wider world.